Hi guys, I'm Yair from Rain the Dog, and I'm welcoming you to PyTest for Beginners tutorial. So let's get started. We'll start with the agenda for today. We'll start by asking ourselves why do we even need to use PyTest. We'll install PyTest in PyCharm and make it usable for our project. We'll write tests by using the conventions, and we also learn how to add asserts. We'll study how to use fixtures. We'll return values and yields. And in the last part, we'll discover what is Conftest and how can we use PyTest hooks. First of all, PyTest is a fully featured testing tool. It's suitable to write small tests, and yet it scales to support complex functional testing. By using PyTest, from one hand you're benefiting from implementing a very easy testing framework, and also you get all the complexity in case you need it. So the main advantages is that PyTest is very easy to handle. It's easy to implement, as I said before. It also has an automatic test discovery. Once you know all the conventions, you don't need to reconfigure them. You can, and we will study how to do it, but you don't have to. Also, it supports hooks and plugins. It can be the built-in hooks, and you can also write your own plugins. It supports fixtures that we will study later on. It's also suitable for large-scale projects with high level of complexity. And because it's an open source, it's getting constantly updated. What do we need to do in order to get started? First, we need to install PyTest package on PyCharm, and then we need to create a custom runner for our tests. Let's start by opening PyCharm. We'll start a new project. Let's call it PyTest tutorial, and then we'll create it. Now that we have completed our project, we need to configure this project to work with PyTest. So we'll head over to the preferences. By the way, it doesn't matter if you're using a Windows, Linux, or Mac machine. You only need to access the preferences. Here we'll search for the interpreter. You can see it here. And I have all the list of packages that are pre-installed in my project. In this case, we have only the pip and the setup tools. So we'll click the plus button, and here we can search for the PyTest package. Yeah, we found it here. You can see here PyTest simple powerful testing with Python version 6.11, and all the contributors of Python, and also you can get the documentation if you'll click this link. So we'll click install package. See, now it's installing, and the package was installed successfully. By the way, you can see here that it also installed all the other needed packages for PyTest, and it was installed automatically. Since our test won't have a main method, so we need PyTest to discover it as a test, we need to go to Add Configuration, and here we can click on the plus button. We'll choose Python tests, and then we'll choose PyTest. Here we can change the name of this custom run configuration. Let's call it Python PyTest tutorial runner, and we can choose from several options. We can specify the script path, we can specify a special module, and also we can have a custom setup. We'll use the default. We can specify a file here. Since I want the testing discovery to discover all of our tests in all of the project, I'll leave it blank. Later on, we'll study how to add additional arguments. We'll click Apply and OK. Now you can see here that we have the custom runner. So in order to execute the test or debug them, you need to use one of those two buttons. We'll start by writing our first test. The agenda for this part is, first we need to understand what is the test discovery phase. Then we'll study about the test conventions. We'll change the testing conventions. We'll use marks, and we'll also use asserts. So let's go back to PyCharm. And we'll start by applying our first test. We'll right click on the root folder, new Python file. Let's call it simple example. The thing here that I can run it, but if I'll try to run it using the PyTest runner, it will say that no tests have been found. So the first thing that we need to do before even writing our test method is to change the file name. The default convention for PyTest is to have the test name as a prefix to our file. So we'll right click on it, we'll say refactor, and we'll call it test, let's say simple example. Now let's check the message again. Okay, now the message is a bit different. It says that the suite is empty. It means that the discovery phase of PyTest have reached this file, but it didn't recognize any test. So let's start by writing the first test. And also in the test name, we need to have the prefix for test underscore and then the test name. So let's call it test underscore my first test. And let's say that the only thing is that this test is doing is printing I'm inside first test, or I'm inside my first test. Okay, let's run it again. So first, you see the green check icon. So all of the tests that were executed under test simple example have passed. And if we'll open it, we'll see that test my first test, maybe it's not the best name in the world, but let's leave it that way. Okay, so test my first test has passed. It took 0 milliseconds for that. And we have all of this breakdown because we are using PyTest. Also, you can see that the test has passed, and we have the message that was printed here in line number 2. Let's try to add another test to the same file. Let's call it my second one. Yeah, I'm not happy with the first name, so let's change it. My first one and my second one. Yeah. And we can print the same message, but now we'll say that we are inside the second test. So let's run it again. Everything have passed. And you can see here the breakdown, the test my first one and the test my second one, both of them have passed. Of course, we can create another file, Python file. Let's call it test second example. Let's define another test in another file. And here we can print I'm the test from the other file. Let's run everything again. So we have two trees that we can open and investigate. The first one is the test simple example, which has two tests under it. And if we'll open the second one, we can see that we have the test in another file also being executed. What do you think will happen if I'll create a new folder and we'll call it second example, and then I will copy the second example to this folder? Do you think that the test will still run? Let's find out. We'll run it, and as you can see, both files were discovered and both files were executed. Of course, that the test discovery is looking for those two prefixes. If I'll change the prefix here to be, let's call it just in another file, and I run it, you would see that this test wasn't executed. From the other hand, if I'll change the name of the file and I'll try to run it again, this file won't be executed. There is another convention for using class. I'll just mention it for a second. Let's create another file. We'll call it OOP. We'll call it test OOP. In order to create a class, we need to start with the prefix test with a capital T. We need to follow the same instructions that we have implemented in the previous files. Let's try to run it now. So let's run it. You can see here that we have the test OOP, test simple example, and second example. All of them were executed. Oh, here I forgot the /n in order to break line. So we have all three tests. Now let's say that we want to study how to change the testing conventions. As we said here, that those testing conventions, we needed the test underscore as a prefix to the test method and also the test file. And we needed the test with a capital T in order to have it in our class example. In order to change this prefix, we need to create a new file. We'll call it PyTest.ini. And here we need to specify three parameters. The first one will be Python files. This one will handle the files. Let's say that we want to use rain underscore star py. This one means that any file matching this prefix rain underscore followed by any kind of text, this is the star meaning, will be automatically detected. Then we need to specify the class, Python classes. we can say that each class that starts with rain will also be discoverable. And the same goes for our functions. Okay, now that we have this file, if I'll try to run my project now, you see that I have the empty suite message. Now we need to handle either that we have two options. We need to change those names of the previous file that we have created, or that we create a new file. That we can create a new file. Let's call it rain, which is our prefix, test example. Now I will say rain art. I will define a new function. We'll say rain underscore my test, and we'll print rain the dog is an awesome dog. Now let's run it. And let's try to understand why it's not running. Yeah, accidentally used underscore check and not rain. And also I need to this one now is a postfix and not a prefix. So let's find out if we can use it as a postfix instead of prefix. So now we'll call it my test rain, because rain is now a postfix. By the way, I forgot to add PyTest here. Let's call it check my rain. And now you can see that rain test example has passed. We have the rain the dog is an awesome dog. And it does match the postfix that we just implemented. So you can see here that we can change the convention to be a postfix instead of a prefix if you would like it. Another useful thing to do is to use marker. I will delete this file in order to go back to the previous convention that we have. Okay, let's run it to see if everything is running properly. Yeah, you can see that. So we can create custom markers in order to group our tests. Let's start by marking this test. So we'll start by providing the annotation, which is called PyTest dot mark. We need to import it, by the way. Yeah, now it's been imported. Now mark, we'll call it sanity. And now let's say that I want to run a subset of all the tests that are marked as sanity, or any other group that I would like. So I'll go back to my configuration, and I will provide under additional argument -m, which is the marker. We'll say sanity. Now if I will run it again, now you can see that the only test that was executed is test my first one, because it was marked as sanity. Of course that I can copy this marker to another place. Let's say to the one here in the second example. And if I'll use this marker here, of course I need to import it here as well. I can execute it again, and now I have two tests. Both of them were marked as sanity. Another useful thing to do is to add multiple markers. So I can have another marker, which I can call it system, or you can call it in any name that you would like. But now this test is a member of two groups. The first group is the sanity group, and the second group is the system group. So if I'll specify system, because it's the only member of this group, that's the only test that will be executed. Now the last thing that we need to do is to use assertions in order to make our test more test-like. So let's add the assertion here. Let's define a Boolean param. We'll call it my validation. We'll say it's false, and then we'll assert my validation. We can also provide a custom message. The validation of this test has failed. In case that the validation would fail, this message will be printed. By the way, let's clear the marker that we had here. So all the tests now will be executed. Now you can see here that we have under test OOP, the test class has passed. Also we have the test class and test using OOP. And here we have two tests, and the test, my first one was failed. And it was failed due to an assertion. Here you can see that the validation of this test has failed, and we also have the error message printed here. Of course, that if I will change the value to true, and then we will execute it again, now all of the tests are now passing. Let's try it out on another test. Usually each test structure needs to have the preconditions. Then it needs to have the test body and the validation or the expected result. We'll go back to this structure after we'll study about fixtures. A fixture is a function that we can run prior to our test. Fixtures give us the flexibility to reuse our code in different methods. In order to define a fixture, we need to use the fixture annotation. So let's go back to this file, or maybe we can create a new file and we will call it Fixtures. You can do it either way, by the way. Fixtures.py. And here, let's start by defining the fixture. We'll call it init web driver. And the only thing that this fixture will do is it will start a new web driver. WebDriver.chrome. Of course, I don't have the package of WebDriver, so PyCharm is kind enough to give me the opportunity to install and import it automatically, so I'll choose this one. Now it's being installed, but it was failed. Why is that? It didn't find any WebDriver package. So let's go back to our preferences. We'll go back to the interpreter. We'll click the plus button. We'll search for Selenium. We found it, and then we can install the package. Now the package was installed successfully. Let's try to re-import it. Now you can see that we have Selenium WebDriver. So now the only thing that line number 5 would do is to create a new Chrome. But nobody is calling this method. In order to use that, we need to mark it as a fixture. So we'll say PyTest. Also, we need to import this one. Fixture. Now this method is marked as a fixture and we can call it from several tests. Let's say that this test wants to use this fixture, so we can provide another annotation. We'll call it PyTest mark use fixtures, and here we can provide the fixture name. The fixture name is the init WebDriver. By the way, we can use a fixture in a different file, but first we need to study how to define a Conftest, and we haven't studied that yet. So I moved the fixture here to this file. Now let's try and run this again. Now you can see several things. If we'll get to the test simple example, let's say this one will print in web. Let's try to run it. You haven't seen it, but the WebDriver was open and closed. It was really fast because we don't have any content yet. But now if we look for this string in WebDriver init, you can see that it was printed only once, because the only test that have used this fixture is this test, the test my first one. And if you go to the breakdown, you can see that this test is the only one that is printing this message. We have another way of using the fixture. We can provide it as a parameter inside the parentheses of this specific function. So let's call the init WebDriver. And now we'll have two instances of WebDriver starting. As you probably seen, we had the blank page of Google Chrome opening. Let's look for init, in WebDriver init, and you can see that we have this one printed twice. The first one was printed here, and the second one was printed in the my second one. Why do we need to use those fixtures with the marker and not use it that way? You've probably seen that this one is grayed out. Whenever we use this fixture that way, we can expect a returning value from this fixture. So let's say that we will return this value, the WebDriver.Chrome. So here we can say that we have a driver, and this driver equals the init WebDriver, because that's the value that we get in return. Now we can say that driver.get, let's navigate to randthedog.com, and let's rerun it. You've probably seen that we succeeded in navigating to randthedog.com. So that way you can use it to return a value. By the way, a very important thing to know, you can have several consecutive fixtures. So let's define another one. Let's call it PyTest fixture, and we'll call it second fixture. Here we can print I'm inside the second fixture. Now I can specify a second fixture, and if we'll rerun it, we can see that, let's look for this test my second one. Now you can see that we've been inside the second fixture. We haven't returned any value from this fixture, but we did activate it before the test was running. So that's a useful way to combine several fixtures to one test. Let's say that you have several fixtures that each one of them is dealing with a different portion of your system, and some tests want to use one part, some tests want to use the second one, some tests want to use them in a different order. That way you have the flexibility to use them in any order that you would like. So what is a fixture scope? In PyTest, we have several scopes for fixtures. We can define here that the scope, let's say that we have this one, the init WebDriver. We have two tests that are calling the same fixture. So I can define a scope, and if I'll define it as a module, it means that only the tests that are defined in this specific module will use this fixture, we'll call it, and it will happen only once in this file. Let's run it and try to find out. Let's look for this string. So you can see we only ran this fixture once, because under this module the scope was to run only once. We can also run it in the function level, which is the default, by the way, which means that each one of the functions is running the fixture whenever it's calling that, and it will be destroyed after each function will finish the execution. So let's run it. Now let's look for this string again, and you can see here that we have this string printed twice. We have another scope which is called class. This scope is more relevant to our test object-oriented, this one, because it's using a class. It means that this fixture will be limited to the scope of this class. We also have a scope of a package, which means that this fixture will be limited to the package that is currently in. And lastly, we have the session. Session means that under this execution, under this whole session, this fixture will be executed only once for all of the tests. Another useful thing to do with fixtures, or generally with PyTest, is to use yield instead of return. Whenever I'm using yield, it means that this value now will be returned to any function that calls this fixture, but now after this will be executed, something here would happen. After the yield. So I want to run it once to show you. By the way, now it's running in the session scope, so only one test will invoke this fixture. So let's try to run it. Now if we look for this one, it was invoked in the second one. So here you can see that after the methods that call this fixture finished, then we got the message that I'm after the yield. Why do we even need it? Let's say that the test was executed and everything was executed properly. Let's delete this one. Let's say that I want to close my WebDriver because it's now been open and I don't want it to be open again. So we can say that, let's start by defining a driver. We'll say that this driver equals this value. We can yield this driver as a parameter. And then after the yield, we can say driver.close. Now this driver will be closed in the end. How do we know that it works? First, let's run it. And this driver was closed. And also the second one. By the way, we're expecting to see this message now twice because two tests have run this WebDriver. By the way, if I will raise an exception and this test would fail here, or it doesn't matter if I will fail my test because of the assertion, this one will be called anyway. How do I know that? Let's comment out the usage of the WebDriver in my second one. And we're expecting that we'll have an assertion error, but we still expect that the WebDriver will be closed and we'll get this message. By the way, we'll get it twice because we have two tests that are using this fixture. So maybe we'll comment out all of these tests. Okay, so let's comment it out. Now we'll have it only once. And the WebDriver was closed, but we have a fail because the assertion was false. Let's look for this string. After the yield, and you can see that it just happened after the assertion error. By the way, it doesn't matter if it is an assertion error, or we can also raise an exception. And if I'll raise an exception before the assertion, we'll have a different kind of failure, because now we had an exception. But you can see that after the yield, it eventually closed the WebDriver and didn't left it hanging out just for fun. So I hope that you like this implementation. Let's delete this one. I want to go back to the thing that we defined in the beginning of this lecture. We said that each test needs to have preconditions. So here we have the preconditions when we use those fixtures. We have the test body. And let's say that we have the expected result. So we expect to see Rain the Dog in the title. So let's say that if we'll go to rainthedog.com, let's try to navigate to this place. you can see that we have RDG automation solutions. Well, okay, let's say we have brainthedog.com here in the URL. So let's go to driver. By the way, you see that it's not auto-completing. We can give a hint in Python, and if you don't know what a hint is, I do recommend that you'll check out our lecture about Python for beginners. It will be linked down below. We can say this one is from type WebDriver. Now, whenever I will refer to the WebDriver, WebDriver, let's say now it's from the type WebDriver. Now, whenever I will use this WebDriver, you see now I have a lot of options. It's auto-completing that. So let's say I want the current URL. And now let's say that I want to assert URL with, let's say this one is the actual URL. And let's change this one to be the expected URL. Okay, now we have the expected one. And we have the actual one. Now we can assert that the expected URL equals the actual URL. Otherwise, we can say expected URL didn't match the actual. Before we'll run this test, let's see. We have the preconditions. We have the test body, so our test does something meaningful. And we also we have the validation in the end. I do believe that you need to follow this structure as much as you can. Let's try to execute it now. By the way, we have the assertion failure not from this test, we have from another one. But we also have the assertion failure here. And it's saying that the URL didn't match because we had brainthedog.com and brainthedog.com/. Of course, that if I will add the slash here, this test will pass. Now, if we'll check it out, we can see that the second one, which is this test, have now passed. By the way, another important thing that you can use with yield, here I close the driver, but in other tests, you can also close the connection to a database, you can close a file, you can close an open connection that you have to a certain API provider. So it's very useful to use yields. A Conftest is a special file that's being used to load external plugins. There are many predefined plugins in PyTest, and you can also write your own plugin. All of those plugins are called hooks, and those hooks will be discovered automatically by PyTest discovery. Let's start by defining the three basic hooks. So let's start by creating a new file. We'll call it Conftest. So under this setup, we can do something that is happening before each test. We can try to initialize the WebDriver, we can try to maybe open a connection to the database, and etc. We have two more useful hooks. The first one will be PyTest run test call. this would be called whenever we're starting our test. So the setup is being called whenever the test starts, the preconditions. So the fixture, it will happen when the fixture will be called, and this one will be called whenever the test will be called. We have the last one of those trio. We can call it run test teardown. Of course, it will get the item. It also get the next item in case that we want to do something with the next test, but it can be left null. Now we can say that, let's say that now we are in teardown. Here would be a great place to close the connection to the database. So let's try to figure out what is happening. So we'll put 3 breakpoints in each one of them, and we'll debug it. First, you can see here that we're inside the setup, and if we'll open this item variable, we can see which test called it. You can see that here the test using OOP, which is this, the test is located here in this file, was calling the setup. This test doesn't have any fixture, so the call will be called just right after. Now you can see that we are still under the same test, and now we are in call. Let's check out what is this test doing. It's just printing I'm inside the OOP test. So let's skip to the teardown. Let's look at the console. You see that the OOP test was printed, and now we're expecting that the teardown message will be also printed as well. Now you can see that I'm inside the test teardown was printed. It was printed only once. Again, now we are again here. If we look at the item, let's look at the item. Now the test that it's called my first one. My first one is using a fixture. So now we are under the fixture scope. Now the test is starting. By the way, if we'll look at this test, it was only printed I'm inside the test setup. Now it was I'm inside the test call, I'm inside my first test, and in the end it will print I'm inside the test teardown. Again, now we're inside the setup. Now the test is, let's look for its name, test my second one. Now a WebDriver was opened and we started with the call. So the WebDriver was opened because it was something that was called by the fixture. So it was under the setup phase. Now we are under the call phase. So we're expecting that this message would be printed. After that, you can see that now we are inside the teardown, and this one will print, and again and again. I hope that you understood all of this debugging session. We have another important hook that we can use. It's called run test make report. Let's define this one. By the way, by using the hook wrapper equals true, we're making sure that this hook will be called in any phase that we are facing here in the Conftest. So the make report is very useful to write to your report or logger. What happens here, that whenever any phase will be called, this hook will be called as well. So let's debug this one now. I hope that I removed all the other breakpoints. Now you can see that we are inside make report. And let's put another breakpoint here. Now we can have the result of the response, and if I'll ask rep.when, let's look for when here, you can see that now the setup was called. So now it's a perfect time to write down to our report or logger all of the stuff that we need to do, because here we have all the parameters. We can say that the setup was passed, and this is the test case, and we have also the model that represented this test, and we can have some other parameters. We can write all of them to a special file such as a logger or a report. So let's go again. Now it was called again. Let's get the outcome, and let's look for the when. Now we are inside the call. If I rerun it, now you can see we're inside the teardown, and again the next time it will be now a different test, and it will be again the setup. Now it's a setup for a different test. So the make report is a very useful tool, and I do encourage you to use this as well. The last but not least thing that I want to teach you about Conftest is that we can create multiple Conftests in our project. We can open our second package, and we can define another Conftest here. Then let's copy this one, and let's say that I'm inside the second Conftest setup. Now if I run it again, I now expect that this test specific will run with two Conftests. The first one is the one that is located on the root here, and the second one is located here, and only this test can see this Conftest because it's in the same directory. So let's look for this one, and as you can see, this message was printed here. It was printed under test second example, by the way. Yeah, you can see it was printed here under this one. So that's it for using the second Conftest. The last hook that I want to show you is the add option hook. By the way, you can go to the pytest.org website. You can write down in Google PyTest, and under pytest.org you have all the documentation. You can look for hooks, and you can see all of the hooks that are already predefined. You see, we have PyTest have many hooks, but for now let's start with the last one. We'll call it PyTest add option. It will get a parser as a parameter, and we can say that parser add option. Let me copy this string. Let's say before we'll complete this method, I want to go back to this specific fixture. Let's say that I want to use either Chrome or Firefox. I want to have my test very independent from the browser that they are using, and I want to have this parameter from the command line. Okay, I want to use the parameter. So whatever I want to do is to use this specific hook, and I will say that I want to get the browser name as a parameter, and I want to store it. Then I can ask for this specific parameter in my fixture. Why is it useful? Let's start by adding the parameter. So we'll open the configuration of this runner, and under additional argument, we can say browser name, and then we'll say Chrome. If you are using a CI/CD such as Jenkins, and you are running PyTest from a command line, you can specify under different executions different browsers. That way you can always execute your tests with a different WebDriver. So this is very useful. The only thing I need to do now is to go back to my fixture, and here I need to use a predefined fixture which is called request. And the only thing that I need to do, let's start by defining the WebDriver. And we can say that if request.config.option.browser name, if this one is equals to Chrome, then we can say that driver equals WebDriver.Chrome. Elif, maybe we can put it in a parameter. So let's say we'll call it browser name. So now we can say if browser name, elif browser name equals Firefox. So we'll say that driver equals WebDriver.Firefox, and etc. and etc. Let's try to debug this one to see what happened. So here we'll start by getting the browser name, and you can see here that the browser name is Chrome, and now this if will start and the correct WebDriver will start. Of course, I can specify a different browser. Let's say that my browser is called Rain the Chrome. It's a browser that they just made up. And now the browser name is Rain the Chrome, which leads us to the conclusion that we probably need to have a fallback browser, so we can say that in any other case maybe we'll start Chrome, so we don't even need the if WebDriver equals Chrome. We can have a fallback. Of course we can add Safari, Internet Explorer, Microsoft Edge, and whatever you would like. So that way you can use parameters with your tests. So that's it for today. I hope that you've enjoyed this video. If you like this video, please give us the thumbs up. You can leave a comment down below to share your thoughts. Any comment that you will leave will help the YouTube algorithm to push this content to many other users, and it will also encourage us to create more quality content like this for you guys. Thank you for watching. If you haven't subscribed to our channel, please do it now. And until next time, have a great time testing.